Hello everyone, and welcome to the GPFM National Pilots webinar series. This is the third in the series, and today we'll be hearing from Spain about two of their projects, INCIT-EV and SYNERGIES. And I'm delighted to be joined today by some of our Spanish colleagues from CIRSE, and I'll be letting them introduce themselves in a few moments. But first of all, for those who may be unfamiliar with Mission Innovation and the Green Power Future mission, I'll go through a few slides here. So let me just go full screen, sorry. Okay, so Mission Innovation was launched at COP21 in 2015, and it's the main intergovernmental platform for accelerating clean energy innovation involving 23 countries and the EU, represented by the European Commission, as well as several collaborating organizations. These members are responsible for greater than 95% of public clean energy research and development investments globally. Mission Innovation is structured around 7 missions, which are public-private innovation alliances that are setting goals that will lead to tipping points in the cost and scale of green energy solutions. And you can see the 7 missions that are on the slide here, but as we are the Green Power Future mission, I'll talk a bit more in detail about that. So the Green Power Future mission's goal is to demonstrate that by 2030, power systems in different geographies and climates are able to effectively integrate up to 100% VRE, variable renewable energy, in their generation mix, whilst maintaining a cost-efficient, secure and resilient system. And we do this through knowledge and capacity building, by demonstrating innovative solutions and generating the tools, data and networks needed to enable more regions to be powered by affordable VRE. Like all of the other missions, the GPFM is a public-private partnership made up of in-kind contributions from its members, the countries and organizations. Italy, China and the UK are the co-lead countries, and you can see on the screen here the many other members that we have in our coalition from around the world. The GPFM splits its work across 3 main pillars. The first is led by China, focusing on the generation of VRE from the likes of wind and solar power. The second pillar is led by Italy and focuses on the grid system flexibility and market design and regulation. And the third and final pillar is led by the UK, focusing on the data and digitalization of the electricity system. And so I'll talk quickly now about the GPFM's first flagship project, which is the 5 Demos in 5 Continents project. So the goal of this project is to establish 5 large-scale demonstrations of innovation activity in the 5 continents of Asia, Australia, Europe, and North and South America, which can demonstrate up to 80% VRE integration by this year, 2024. And these demonstrations are made up of 80 national pilots on the scale of millions of euros and aimed at reaching technology readiness level 6 to 7. Each of these national pilots is tackling one or more of the 50 most urgent innovation priorities identified by the mission and is driving towards 80% VRE integration. You can find more detail about all of the pilot projects in the National Pilots Report published on the GPFM section of the Mission Innovation website, where you will also find more of our core documents such as action plans and annual reports. So on to today's agenda. So as I've mentioned, the main goal of the GPFM and Mission Innovation in general is to facilitate knowledge exchange between its members and other interested parties, to catalyze and accelerate innovation around the world. And so that's why we've set up this webinar series, so that all of you, the pilot project leads and other innovators, can discuss ideas, progress and lessons learned along the way. This is meant to be quite a relaxed exchange where our project leads will give some short presentations before we open the floor to everyone for some fruitful discussions. And so today we're featuring our colleagues from Spain who are going to give these 2 presentations on SYNERGIES and INCIT-EV. And then just before we get started, I want to show you the webinar schedule as it stands so far. So you'll find the links to the recordings of the 2 previous webinars on the GPFM website or through our LinkedIn. And then today, of course, we have Spain. And then in the following months, we will have talks from National Grid on October, and in the UK in November, and that's the webinar that was unfortunately postponed from June. So keep an eye out for updates on those. And lastly, just a reminder to submit your questions at any time throughout both of the talks, and we'll get to all of them at the end. And you may also raise your hand if you want to be unmuted, and you can ask your question verbally. And with that, I'll be handing over to Maria to give a brief introduction to CIRSE. Maria.
Thank you very much, Greg. Thank you for the invitation. I'll be sharing my screen right now. Hopefully you're seeing my presentation now. So good afternoon, everyone. My name is Maria Izquierdo, and I'm the head of project management at CIRSE. So thank you very much for the invitation today. As I say, it's an honor to be here to exchange knowledge. So thank you to Greg and to the organizers of the Power Future Mission Innovation. Before we dive into the exciting projects and best practices that you will hopefully get and that my colleagues will present in detail, I'd like to start by giving a short overview of CIRSE and how we are driving innovation in the field of sustainable energy. Well, CIRSE is a technology center in Spain composed of 300 people, basically dedicated to bring innovation to the business sector. So in CIRSE, we can say we have a depth understanding of the market, so we can bridge the gap between research and the needs of the business sector. Our goal is to transfer viable and profitable solutions to companies in the field of energy, sustainability, resource efficiency, energy networks, and renewable energies in general. Okay. So as I mentioned, our mission is to transfer technological solutions that are able to anticipate the challenges of the future and to improve the competitiveness of the companies we work with. We are 100% self-funded, which means that all of the center's income comes from or either competitive public programs or private contracts with companies, as I was mentioning. So our activities based on two main pillars. On the one hand, we have applied research, mainly carried out in the framework of collaborative research projects. As you can see there, we have 72 projects in Europe, and we coordinate 20 of them. Okay, and on the other hand, we also do technology transfer and high quality services to companies, as I was mentioning before. We have a 50% success rate in competitive European projects. So as I mentioned that we are more than 300 people, we have 30 years of history, and our headquarters are located in Zaragoza in Spain, and we have 2 permanent delegations, one in Madrid and one in Brussels. So at CIRSE, we promote the transition to a cleaner and more efficient and sustainable energy system through the work in the different areas. You can see an overview here of our lines of activity, all of our projects. Let's say we could fall into all these topics. So the CIRSE's strategic lines align with this mission goals in several key areas. You can see here we have renewable generation. We work in wind and solar and other renewables, helping to increase the share of VRE in the energy systems. Also, you can see smart grids and digitalization. We work developing smarter solutions for more flexible grids. It's essential for VRE integration. Also, we have hydrogen technologies. This storage supports balancing the VRE supply and demand, while enhancing grid stability. Also, of course, decarbonization projects, which are focused on reducing emissions and contribute to greener and more sustainable power generation. So here you can see some of our clients. We work for the main companies in the energy sector. And also we play an active role in several national and also international platforms. Here you can see some associations and platforms. We play an active role here. And moreover, with regard to the Green Power Future Innovation Initiative, well, we participate in 3 national pilot projects which have been flagged by the mission. And as Greg mentioned, we are presenting 2 of them here today. The INCIT-EV project has been completed before summer. And well, we are coordinators there. And I guess it addresses the challenges you were commenting on Pillar 2 related to system flexibility and market design. And on the other hand, we have Synergy project, in which we are participants, we don't coordinate. It's currently at the halfway point of its lifetime, and it focuses more on innovations related to data and digitalization of system integration. So that's all from my side for now. I like now to hand the floor over to my colleague, Miguel Zarzuela. He's project manager in Cirte. He's the project manager and coordinator of INCIT-EV, and he will dive into the detailed insights and outcomes of this exciting project. And thank you once again for this opportunity, and I hope we'll have inspiring sessions and knowledge exchange. Thank you very much.
Thank you very much, Craig and Maria, for this kind of introduction, and I'm very happy to be here today. As said, I'm today representing INCIT-EV project. This project has ended just this summer, so we are at the perfect time to share with you the results and outcomes that we have produced until now. Before I go into the details of the project, and given the objectives and our contribution in the Pillar 2, I would like to highlight that it's depending more and more, but it is increasing, that in several hours, in many hours, or if you evaluate the change of prices in the spot markets for electricity in Europe, in less than 10 hours, you can change more than 100 megawatt hours of spot price, and even to have negative prices. So this was a day during the day due to a peak of solar production during this summer, and after this spring we are having more and more solar production that is giving down the prices of the electricity, while at the sunset we are having spikes of cost. This is because the cost of running gas peaking central stations is getting expensive and expensive, and on the other side the renewables are getting cheaper and cheaper. Why I'm introducing this? First, because depending on the hour, here you can see Holland and Spain. If you are using the electricity in the central hours of the day, you are going to have more renewable share, so less carbon intensity of the kilowatt hours that you are consuming, and you are avoiding to use these fossil fuels out of the renewable times in which they are higher. Why I'm telling you this is because we can speak today about demand side flexibility from EVs, and this will be a huge, important topic for today and for the next days in order to match the variable renewable production with a demand side flexibility. This is part of the INCIT-EV project that I'm presenting today. Just you to know, it was a project that lasted 4.5 years. We ended in June this year. It has a budget of 19 million euros, and it was focused on electric vehicle charging technologies. We have 7 use cases located in 5 European cities, and we have mainly covered the fields of smart and bidirectional charging and also inductive charging. I will go later into details. Just wanted to highlight that we are more than 33 partners in this consortium, including 3 OEMs as Stellantis, Iveco, or Renault. We've been participating several research and technology centers as CIRFE or BDCOM, other technical experts in all the fields, construction companies, universities, and also the municipalities of the cities that we have participated in this project. Mainly what's the main goal of the project is to develop and to test an innovative set of charging technologies and its associated business model to improve the EV users' experience with the ultimate goal of fostering the EV market share in the European Union. What we have done during this time, first we have shared among the EV users their preferences and expectations when they are charging their vehicles, with the aim of, in the end, find a more interpretable solution for them for easiness of charging, but also with the aim of having lower cost from the final users, but also from the charging point operators, with the additional objectives of avoiding grid congestion and make use of smart charging. We've been also focused on wireless charging. This project has been the first international consortium tackling interoperability to achieve wireless charging from several wireless charging systems from different manufacturers. We had 3 use cases, and we've been able to charge from 30 to 90 kilowatts in static and dynamic, reaching urban speeds on dynamic charging. We've been working also on bidirectional charging. We have developed low-cost and scalable bidirectional chargers that have been tested from the scale of 3 kilowatts until 25 kilowatts, in which we have been able also to test what is the improvement of the smart charging, that is the possibility of inject energy into the grid, not only manage when you are consuming this energy. And also, now that we have finalized it, we've been able also to determine the business models and the pricing of all the technology that we have been used, and also some standards and regulation recommendations based on the project development. I'll invite you to search on the specific data that you want, because we have public deliverables that we are releasing right now, and some useful information can be used for other projects. Let me just gather some of the information that we got from the users from more than 5,000 surveys. What the users want, of course, is to have cheaper EVs that runs longer, that have more range and charge very quick. But if we transpose that to what we can do from the infrastructure of charging, we need seamless, smart, and reliable charging for the users at home, but also when traveling, when they really require fast and interpretable charging for travels. We really require slow, cheap, and manageable charging at home or at work when the vehicles are parking and there is no need to have fast charging, where at the same time we can integrate the EV batteries in the smart grid, because there is an increasing desire from the final users to use their own batteries as batteries for solar charging, but also as batteries for energy backup. On the other side, from the point of view of the grid operators, they are more and more interested in having storage in the grid to manage the generation and also the unmanageable demand. And for that reason, they are looking for the EVs as storage as renewable energy sources. So they can participate also as flexible demand side, and they can provide smart charging and ancillary services in which they can support frequency, voltage, reactive regulation, and even phase load balancing. So this is what the expectations that we have born from the final users and the grid operators. And then I will start with some of the outcomes that we got from the part of the project related to smart charging. We had a unique demonstrator in the Netherlands where 200 charging points in the Netherlands operated by TotalEnergies have participated in congestion markets. What we have done in this project was to develop a smart charging algorithm in which we can control the maximum power at which the public charging points can charge. So in the bottom of the screen, you can check in red what is the base load for the power of the charging points aggregated. And what we have done, we have participated in congestion markets. Therefore, in the Netherlands, this specific grid is very congested. So the grid operators, at some points, they need to reduce the demand of some of the consumers in order to guarantee the stability and the security of the grid. So in that case, we've been able to participate with more than 100 kilowatts of switch, and we can reduce the power at peak hours when the grid operators require this, and receive a small fee for reducing this. And then this charge is abated, is reduced at peak hours, and is moved to the hours before. So we've been able, if you have a more aggressive or less aggressive smart charging algorithms, you can move this demand in these slow charging points or semi-fast charging points. They were 11 kilowatt charging points in which the demand can be moved to the valley hours after the congestion is released. What we have done also, we've been working in bidirectional charging under the last standard of the ISO 15118-20, which unfortunately is not totally fully commercially available, but we've been able to test, to have some tests with the OEMs involved in the project. We've been testing this on AC level and on DC level, and I will say at the end of my presentation, what we are lacking now is commercial implementation of these communications for the bidirectionality that allows charge and discharge the vehicles. On the other side, we have also included super-fast chargers with frequency control and grid support managed by the DSO directly. This has been done in Estonia, in Tallinn. So not only low power chargers can provide grid supports, but also super-fast chargers can increase the grid stability. We've developed also a decision support system in which it is devoted for city planners, and where we can make an optimal sizing of the sites of the charging points of a city, given an expected fleet of EVs that we are going to have in the following years. So this tool really helps the city planners to manage or to plan the infrastructure needs for EV charging in the coming years. Coming into the details of some of the use cases, this is one of the bidirectional chargers that we have developed at FIRFE. This is a 25 kilowatt charging station with 2 outlets of between 11 and 25 kilowatts of output. In this case, we have used CHAdeMO and CCS, mainly because the power electronics is totally bidirectional, but on a CHAdeMO vehicle, we can test it successfully, but on CCS, on commercial vehicles, is not fully available. In this demo, what we have performed is vehicle-to-grid operation, but also we have charge from vehicle to vehicle without using the grid. So we've been discharging the Nissan vehicle to charge this Renault vehicle on the other side. The goal of this design is that we have achieved low cost and a very high charging efficiency by the use of silicon carbide MOSFETs. So in this case, we have obtained on the charging process a 97% of charging efficiency with development of high frequency transformers in the magnetics used in the charger, and we perform also tests of what is the efficiency of charging and discharging a vehicle, and we have reached 90% of the whole charge and discharge process. So we can use 10 kilowatts of the grid, and we can return 9 kilowatts again to the grid if we are using the electric vehicle as an energy storage. I will just highlight some of the results that we have for wireless. This is not totally related with the information with the Pillar 2, but is a technology that can improve the use of electric vehicles. So therefore, fostering the switch to electric vehicles and to have additional EVs that use renewables in the roads. So we had 3 use cases. The first one is static and aim to charge e-taxis. In this case, we have one charger that has been installed in the we have here a wireless power transfer in which we have one coil installed in the ground and then one coil installed in the vehicle. This allows that when a taxi enters into this station, automatically, and even while they are moving in the queue, they can start charging. So we are able to charge up to 50 kilowatts. In this project, we have used 30 kilowatts coils on the secondary that were installed in the Renault Zoe. So we've been able to test about 85% of charging efficiency on this use case. We have not stopped here. We had also dynamic wireless charging. So in this case, we've been able to charge in the streets of Paris, and we've been able to use a 30 kilowatt charger. The same that you said in the all. The goal of this project is that all the vehicles were installed with the same secondary coil. So we have 3 different primary coils, and all of them were interoperable between them. In this case, we have the same charging, but on the move. Therefore, on the same time that the vehicle is moving, the coils beneath the asphalt are activating and deactivating one by one while the vehicle is moving. This allows to even without stopping charge the vehicle. So for captive fleets or even for other vehicles that are equipped with this technology, or in the future if this standard gets more interoperable and can be used on open streets, it allows that while we are traveling or we are on the streets, we can charge our own vehicles. Here in Paris, we have demonstrated this technology with one DS3 and one Renault Zoe, and we have also used one Renault Master that is bigger, and we have used 3 coils beneath the vehicle so we can increase the power. In this case, we have successfully tested 2 of the coils. So instead of charging 30 kilowatts, we were able to charge 60 kilowatts. And finally, the the last design of the wireless charging was low cost dynamic charging focus on high speed tracks. The goal here, as you check on the previous slides, we had 1 meter coil each meter. So every meter we need 1 inverter and 1 coil. In this case, for the long speed travel, we have developed longer coils that are able to charge on the streets with a lower cost. So here the goal was the same. We have designed longer coils of 10 meters. So we had 10 times less of power electronics. We are powering one inverter per every 10 meters. In this case, you can see it here. With less coils, we can cover longer spaces. So the cost of the installation, which is quite important, is reduced. Here, if we are planning the roads at the same time that we are building the roads, of course, there is an additional cost of about 1 million per kilometer. But this is not that much in comparison with the construction cost of the roads. Depending also on the scale, we are now at prototype level. These costs can be reduced. In overall, the efficiencies that we have obtained for these chargers are between 70 and 85%, depending on the operation, the misalignment. And just finishing, I have used a little bit more time. Just finishing with the conclusions concerning inductive charging, we've paved the standard for interoperability, in which with different manufacturers of the coils, we've been able to charge the same vehicles on 3 use cases. Here the goal is to work on further standardization on the secondary coil definition and the onboard charger to allow interoperability with additional manufacturers in the future, and also to allow misalignment operation on the move. From the other side, from conductive for smart charging and bidirectional charging, what we see is that we need the vehicles are capable right now for smart charging. This is not a problem, but it's not used with the highest possible optimization that can be done right now. Therefore, we need to have additional demand side flexibility in order to have with the same grids additional power for charging more vehicles or to absorb more renewable share. And at the same time, this will allow the EV users to reduce the cost while charging. So you can reduce 90% of the cost if you charge at the lowest hour during the week. But also, where I was also, if you are using bidirectional charging, we have determined that the charging of the vehicle can be totally free. So in the case that we can charge and discharge the vehicle, the users, for offering this flexibility, at least they'll have free recharge. So we have to unlock this impressive potential of bidirectional charging to increase the grid battery storage, which is the big topic for the coming years, to allow even a higher renewable share. What we are lacking is the really use of this standard, the ISO 15118-20, from the vehicle side, as the chargers are ready, the manufacturers of the chargers are ready, but the vehicles are not there. Therefore, we cannot fully implement this, and this is starting to be a problem for the final EV users, in which this has been promised since several years, but the reality is not reaching their households. Just you to know that we've been working with other projects as USRC or Charge for Drivers, and in terms of smart charging and bidirectional charging, Escape project is taking the lead of this after us. So the conclusions that we had are being used in other projects, while this one is right now ending. So I will end here. As Craig said, you can put your questions in the chat, and we will be able to answer your questions at the end of the session. And now I will end my presentation. I will be turn of my colleague, of Emiliano Mesa, also project manager in the same department in INCIT-EV as me, that will present the next project, the Synergies project.
Hello, everyone. Thanks for the opportunity to share the project insights here for the synergies, as introduced by my colleague Miguel. My name is Emiliano Mesa. I'm project manager here in CIRCE, and I'm going to present the project synergies, where CIRCE is taking the role as a participant. Firstly, let's start with the synergies overview, which is the shaping the consumer inclusive data pathways toward the energy transition through a reference energy data space implementation. Here, with almost 80 million euros of fundings, we're working 42 months. We're now in a little bit more in a half of the project. And the coordinator, Suite 5 and TXT in the project have the technical control of the project, and in our side, the CIRCE is playing the role of the RTO, supporting one of the demo sites that we will be presenting later on. It's also important to mention here that we have a background information with the Synergy project that ended in December 2023, where we are taking some working assets and also some references to avoid this duplication of efforts of work and the synergy between the both projects. So why do we are working on this project? We are basically working on energy and data, and these are the challenges that has been addressed in the call that the synergies was proposed as a project. Those challenges are the integration of a wide range of new energy solutions and the first of a kind technologies on all the levels of the energy system, and also to give flexibility and promote and efficiently manage, on one side, self-generation and consumption profiles, and on the other side, the new holistic solutions for energy storage. For example, the surplus energies, the peak load supply, and also the intersectional storage. Finally, one of the challenges as well is the acceleration of the sustainable energy transition by the use of these opportunities arising from the digital transformation. So our approach, our vision of the project is defined according to those defined challenges, including as well different energy data stakeholders such as DSO, TSO, and also prosumers that they gave a great value that we think that we can provide by having some communication between them. Firstly, we have the physical layer, all the distributed data sources that we are having coming from different files, such as building, vehicles, and also energy resources that are disconnected, that are not sharing data. And thanks to synergies, we have four main concepts that we're working with. We're working with the security and sovereignty. We're working with data interoperability and governance, the trustful sharing, and also the value accrual in the sense of making the possible and accessible to extract value from those data. Finally, the proposal of synergies here is to bring forward this reference energy data space implementation that attempt to unleash the data-driven innovation and sharing potential across the energy data value chain by leveraging on this data intelligence coming from these diverse energy actors. In terms of consortium, It's important to mention that we are 22 partners working in 4 different knowledge domains. Those 4 knowledge domains are also crucial in the elaboration of the project because it gives a great insight about we're not only energy, it's not only working about either data, but also we are including the business and the social perspective in the project thanks to the expertise of the whole consortium. And okay, we've been talking about energy data spaces, but what's this concept? To be honest, we don't have a real common definition so far. We have several different organizations and working groups working on that concept, but each of them give some highlights in different positions. So at the beginning, we decided to create this concept and to make our own work in a real market and land this work in the real market. So the Synergy data space is a secure and isolated data sandbox that is provided or is available by each of the stakeholders with the objective of collect, control, monitor, analyze and share those data in their own terms, and also to obtain access and use external data. So through a reliable, interoperable and autonomy preserving approach, we are enhancing the data-driven intelligence and also increasing this data outreach. As mentioned, this is one of the definitions that is considering different perspectives from other organizations as Bridge, European Commission, different boards such as ATPSnet, Energy Data Spaces Project Clusters. So that helps to understanding of the future part of the presentation. Well, talking about objectives, these are the main objectives, both in terms of scientific and also business visions. And the inclusive ecosystem of these stakeholders planning the project facilitates the achievement of all the objectives. For example, this increase of the involvement of energy data value chain stakeholders. It's also part as well of the engagement of the prosumers. We also take into consideration this data sharing driving ecosystem. And also on the other side, those digital solutions are also helping on this on delivering these energy services with those novel business models. We will be validating as an objective in 3 different demo sites, and the fostering of energy communities is also among our objectives. So going to the solution that we are proposing, as mentioned earlier, this inclusive ecosystem concept is one of our keys. And here we can see how we are working with 4 different layers. Starting from the physical layer on the bottom, the green one, we can count on those distributed assets with some uncertainty control and even some of them not being reachable. So Synergies plan to integrate them with the 3 different layers as the business integration, the market integration, and also integrating with the services that we are developing and also with the existing one. To be more specific on the developments we are doing, the service integrations, there we present some developments such as the development of 4 digital twins for prosumer and buildings, for community, those real-time network, and also the short and mid-term network. And furthermore, we also have 6 energy apps developed in the project for smart building, for EV charging, some asset management and predictive maintenance, and that we will be talking about that afterwards. The TSO, DSO, the operational scheduling and flexibility marketplace, the local flexibility marketplace, and also the investment planning and prioritization. Furthermore, we also integrate in this service level the marketplace and the AI analytic platform. Well, talking about the demonstration, we have 3 different demonstrations, one of them in Greece, another in Spain, and the last one in Denmark. And we are working with 8 different demo cases and a big amount of data assets that are being gathered to start working with the real services. The 8 demo cases are listed here. The first part is the title of the demo site, and then we're also mentioning how the data flows among different stakeholders. And also we are tagging where the demo site is being tackled in each of the project, in each of the locations. The 8 demo cases, the first one is about the proactive flexibility aware network management. There's another one about collaborative and transparent operational scheduling and transmission for distribution network. This data-driven network asset management and predictive maintenance is the one that we are working from Thursday. This is our development. Then we have another one for this demand response for the dynamic virtual power plant. We also will work on one demo case for local energy communities, another one for Icelandics. The seventh one is about consumer engagement, empowerment, and the last one is about the promotion of this green energy investment through this informed decision making. When talking about this demo site that we are working in CIRSE, this app about asset management and predictive maintenance has two different modules. The first one, the grid incident monitor, is gathering in a GIS-based analysis all the incidents that we are having. So we have an historical data there. And also we identified some hotspots on a map to know where the more sensitive area to take care of. And then the predictive vegetation maintenance scheduler, it's also on a GIS-based analysis, and it shows a time to act for planning on a map, so we can plan accordingly the operation and the maintenance work for the grid. As mentioned, we are in the half of the project. We are not in the same level of advance as INCIT-EV presented by my colleague Miguel. But I would like to share here the part of the progress, the ongoing work, and also some of the lessons learned that we have at this stage of the project. Firstly, an important milestone in the project has been the first release of this energy data space platform. And there we also have the first version of the digital twins and the energy apps ready, even if they are not fully integrated now in this energy data space platform. We are now on the process of this data ingestion, so we are collecting those data to start with this early testing. This also means that we accomplish a former big milestone for us, this definition of the architecture, the different use cases tested among the different demo cases, where we were gathering more than 110 requests, and also the detailed specifications to make this possible. We were also considering the physical asset landscaping, and also the procurement in the project has been planned up to now, where we will be able to work with sensors, with EV chargers, and also even batteries. The second release of the platform, where we have the integrated apps and digital twins in the data space, will be happening in the upcoming months. And finally, according to the lesson learned that we can share up to now, in the project execution, we were realizing that the willingness to share this energy data with the other stakeholders is not as easy as initially expected. So it's also important to provide something in return to those energy data provider, even if it's a revenue, even more data or benefits in any way. Linked with that problem in the exploitation side, we were thinking that the cost of this data would be an important point, an important part of the business model to be considered at the beginning. And also this change, this affection can be make this business model be profitable or not, because due to the difficulties to get those data, making some expenses on buying them can make a difference. In terms of communication, the concept of this energy data space and the importance of the collaboration from the general public for prosumers for example, is also a challenge that is not an easy and straightforward message to deliver. So we have to adapt those communications channels and this communication to the different energy stack stakeholders. And also, finally, with the technical lesson learned, these energy data spaces are something trending, but the alignment is still elusive. And also, those in-depth specifications are mentioned were a real challenge for us to be delivered. So these deep down definitions are crucial to have a better implementation afterwards. And that's all from my side. If you have any question, you can post them in the chat, and we can also tackle them. Thanks.
Okay, thank you very much to both Emiliano and Miguel before that. So yeah, feel free to post your questions in the Q&A at any time. And so while you think of some questions for Emiliano, we can cover some of the questions that have already been posted for Miguel. So the first question comes from Arena. So she says, thank you for the very interesting project. Wondering about in the first smart charging project, the operator shifts the charging demand based on grid congestion with the consumer's approval, or does it have control over the demand? And is there any remuneration for the driver for providing these services? And then secondly, is there any conclusion in terms of how much saving can be done in grid reinforcement by using smart charging of electric vehicles? So Miguel, I'll leave that to you.
Excellent. Very nice and relevant questions to dig on this topic. First of all, and this is how they have managed this in the Netherlands. At the beginning, they think about having a disclaimer and an opt-out option. But the truth is that these charging points, if you are charging, you are automatically accepting this possibility of reducing your charging power while you are charging. Therefore, the consent is at the same time that you are applying the terms of charging. But there is an option of opting out if you need to charge. However, if you are reducing 100 kilowatts in 200 charging points, the reduction in power usually was less than 1 kilowatt or 1 to 2 kilowatts. So they got almost no complaints about the reduction in power. This is because this was not an aggressive smart charging algorithm. What was one of the conclusions? That really to achieve higher improvements in cost savings and also in congestion fees gained through participating in these services, you do really need at some point to stop the charging points or even to reduce it to 6 amps, which is the minimum that the EVs allows. At this point, and as this was a test just to that is possible on a public grid, public operated charging infrastructure, to implement these smart charging algorithms, because originally when we had problems as it works on real time, we had problems in delays on implementing the reductions. So this was a process of optimization and testing. And we don't have specific numbers of how much savings can be provided to the end users and to the CPO. But of course, if we are having higher and higher situations of these important changes of cost between hours, so if you can avoid charging at 8 p.m. or 9 p.m. and moving that to the midday or later into the afternoon, the savings can be even 50 to 80% of the tariff cost to the the CPO in charge of buying this energy. But for the final users, we at this point there was no incentive. But dynamic tariffs is something that is still in place, and there is an option in which if the user can charge at these low cost times, they will get cheaper fares. But this was not used. But is a conclusion and immediate conclusion of using these services.
All right, thank you for that very comprehensive answer. We'll move on to the next question, which is from Luciano. So he says, thank you for the very interesting presentation. Could you confirm that what you presented for compact electric vehicles in terms of inductive charging is also relevant and interesting for buses and other heavy-duty electric vehicles? He has done something similar in the heavy-duty EV context.
Yeah, absolutely is relevant, and also some projects are moving to this high power wireless charging of 200 or kilowatts or even more. The good part of the heavy duty vehicles is that you have more space. So you can easily integrate or to have more coils in the same vehicle. So increasing the power is not such a problem when you are talking on compact or light vehicles. Also, the problem that if you are really increasing the power and you are going to have a sustained charging, you will need refrigeration of the coil. So also, if you have enough space, you will be easier to implement these refrigeration or cooling systems of the coil if you are maintaining higher loads during longer times. So absolutely, yes, it's totally interrelated.
Okay, great. There's another question here for Miguel, and it's come from Arena again. So she says, wireless charging, especially dynamic charging, is technically possible, as you've demonstrated, but does it make sense economically? Do you see this solution as having real potential to be scaled up? And is it more suitable in the context of highways or inside cities?
This is the big question for inductive charging. Right now is too early to have real industrial scale costs of what will be the system of integration, because we've been discussing this with the partners. Really an integration of in this case we had an onboard AC/DC that transfer the power from the AC of the coil to the DC power at the right voltage of the battery. If we work this for massive deployment, we can optimize or even use the same onboard charger for the grid or the inverter for the motor, and we can, with the same power electronics, we can use the same ones. So this will reduce the cost on the vehicle side. On the infrastructure side, this is depending if you are if you have a captive fleet. For example, the taxis for static charging, this was the most profitable solution because they are stopping on fixed charging stations. In this case, the coil of the ground was refrigerated by oil, so it can operate the full day. So only with one charger, with 50 kilowatt charger, you can really have a great rotation. Therefore, the cost of the charger is not that much. It's a little bit more than the ones for conductive charging, but it's not that much. So here you can have the same business models as you are having right now for quick chargers on the street. The topic of dynamic charging, this is where if we have more vehicles capable of charging and that really using, so the key is the rotation. The key is if this infrastructure is being used, you can check our business spreadsheets, and we have determined how many vehicles at which price, how many megawatt hours we need to sell every day in order to make profitable this infrastructure. So in the end, it depends on how many vehicles are equipped and how many vehicles really need to charge. Because if you are moving for cities that you have enough range, you are not going to pay this cost of charging if you don't need to charge. So it's a complex question. I will say that we are 5 to 10 years away to really see the dynamic charging really moving into a commercial application. But on the other side, for the static one, we really see that this can be implemented as today if we achieve the interoperability between the different manufacturers. But really interesting questions you've made.
Great, thanks for that. So we have another question from Peter. He says, thank you to both presenters for the very interesting presentations. And he has another question for Miguel. So how does the availability/supply chain of the magnetic materials used in the dynamic charging systems affect the potential scale-up of the technology?
That's also a very relevant topic, because it's well known that for the coils we need to use ferrites usually in order that the magnetic field is effectively used in the vehicle and not in the surroundings. But in this project concerning the long range solution for the dynamic charging, the 10 meters coils that I have presented before, they were made without ferrites. So this solution only use a copper coil, a copper wire beneath the asphalt, one turn, so 10 meters one way and 10 meters the other way, separated about half meter, without ferrites. We have a little bit higher losses than if you are, of course, using ferrites. But as we have the vehicle that is running on the track, it's shielded, and its coil was really designed for the interoperability of this infrastructure. For the vehicle, you only need one coil, and for the road, you need a lot of coils to cover the kilometers that you are covering. So in this case, with only copper, so without using ferrites, we've been able to successfully charge. It's more complex in the control of the system, but we've demonstrated that it's still possible. So there are solutions to avoid using these ferromagnetic materials while using some more simple, let's say.
All right, great. Thank you for that. So there are no more questions currently, but let's see if we can get some questions for Emiliano now. And so I'll ask the first one to Emiliano. So you mentioned in your lessons learned section about one of the issues that you're potentially having is the willingness of stakeholders to share data with each other. So my question is around sort of the governance of this. So have you given much thought to the future governance of this? Will there be standards in place? Will people will the stakeholders be essentially not forced, but essentially forced to share their data with each other, maybe in certain ways? Will there be a governing body overseeing all of this in order to make it happen?
Thanks for your question, Craig. At the moment, we were developing a first deliverable about socioeconomic barriers and analysis from this energy and data space perspective. And there we triggered this lesson learned at the beginning. With the legal and business colleagues, we are working on that approach now. And in the upcoming months, we will be thinking on that governance body having this control of the data. At some point, this SYNERGIES is pursuing the security of those data, and even if this isn't interoperable and we can exchange and share data, making sure that each of the data owners remains the owner, and the sovereignty is ensured with the sharing as well. So the change of the concept about working in siloed data and now with the synergies is this change of data, but this governance is still in the plate for the upcoming months.
Okay, great, thanks. And a question has just come through from Luciano for Emiliano. So with regard to the data space, could you make a comment about cybersecurity threat implications, things through your communications, your data platforms, etc.?
In that sense, I'm sorry I cannot provide many insights on that. Technical coordinator is our colleague from Suite 5. So those challenges are specifically dealt from their side. I'm sorry that I cannot provide many insights on this sense.
Yeah, no problem about that. Perhaps Luciano can reach out.
Yeah.
All right.
You can reach me by email, and I can transfer this question back to you according to the answer.
That'd be perfect. Thanks. All right. Well, there doesn't seem to be any more questions appearing. So I think we've made good time there. So one quick thing I'll do before we finish up is just share my screen one more time to make everybody aware of next month's webinar. So that will be on the 11th of October, which is a Friday, and it'll be at the same time as it is today. And we'll be featuring National Grid presenting 2 projects again, and both quite similar to the projects we saw about today. So vehicle to grid and also the virtual energy system. So stay tuned for updates and invitations to that. But I think with that, we will call this to a close, and we'll thank again Maria, Miguel, and Emiliano from Circe. And thanks to everyone for attending, and we'll see you at the next one.
Thank you all. Goodbye.
Thank you very much for the invitation.
Thank you very much.
Have a nice day.
You too. Bye-bye.
Thank you. Bye.
Bye-bye.